Hi folks, Chuck Black here. We are doing 52 weeks of Python and we are in week number 29. If you recall, the last session we did NAPALM, or we started with NAPALM, and we looked mainly at how you can get information from your devices in a nice, simple manner using NAPALM. In this lesson, we're going to look a little bit deeper at how you can actually compare configurations and maybe even start to take steps towards writing configuration. Although we don't write it here, we do mainly comparison. Why would you compare configurations? Because you may be interested in finding out if your devices are in compliance, as you can see from this Quakka screen right here. Now I'm comparing software versions to make sure they're in compliance with what I think they should be. And I'm also comparing the configuration. Now these sandbox devices are constantly changing, so as you might expect, they're constantly out of compliance with my standard. But that's what this does. How does it do it? It uses NAPALM and the functionality that's provided within NAPALM, some of the methods to load replacement configuration, and then to compare the configuration. That's what we're going to be talking about. So I'm going to have some code that we're going to go through, similar to what we did before, but this time we're going to be checking to see if the configuration compares with one that I read immediately beforehand. And then we're going to look a little bit at how Quakka actually uses the same type functionality in order to get the nice user interface here. I think it's a nice user interface. You can make your own judgment. Anyway, that's what we're going to be talking about. So without further ado, let's get started. Okay, so let's continue our discussion of NAPALM. Now, the last lesson we talked about what NAPALM did for you, how it helps to handle the details and the differences between different device types, supporting multiple products, even multiple vendors, taking care of all of the details related to communication with the device, and providing a nice, pretty simple interface for using it. And last session, we talked mainly about getting data from NAPALM. So we got environment, we got facts, we got interfaces, interface counters, things of that nature. In this lesson, we're going to talk about NAPALM and configuration. So that would be mainly checking the configuration to see if we can merge data, if there are differences, things of that nature. And so to put it in context a little bit, if you've seen Quakka before, you know that we have all these different tables. We have a devices table, we have hosts table, we have services table. All of these things you can drill down into and get interesting information about. We can look at events, etc., etc. I usually just gloss over this compliance table, and that's what I want to talk about today, this compliance table. Now, you can't really drill down to do anything more compliance-wise, but what this is intended to do is this. It's intended when we go out and we monitor these devices, it's intended to help us to know is the software version up to the standard software version that we have decided we want to have for that particular type of device. And then we want to check, so that's the software version compliance, and we want to check configuration compliance. That is the device configured according to some standard that we have set up. Now, this is something that real people do in real environments, and I've worked on a project that did that. My Quakka implementation is very simple, and so it's almost trivial in what it does, but it does use NAPALM, and so we're going to look at some of the functionality of NAPALM and how it does it. If you have run Quakka before, you probably are used to seeing these configuration things be red. That is because in my implementation, I ran into some issues with NAPALM and was not able to resolve those, and so I moved on to doing other things like packet capture, traceroute, extended port scans, workers, remote workers, things of that nature. So I did a whole bunch of other stuff rather than dwelling on configuration. Now, the problems that I ran into with configuration do revolve around napalm. And I want to draw your attention back to this slide that I have here. Remember, I showed you this beautiful slide that talked about the things that I mentioned. It handles all the details and the differences don't matter, and it works the same for every device. Well, I don't know any other way to tell you this except that I lied. I didn't really, it's not really my lie. It's these are the intentions, the aspirational goals of a product like napalm. And sometimes it's possible to meet all of them, like a lot of the stuff that I showed you in the previous session. I could do things and it would go out and get the information and return it to me in a common manner, and it worked beautifully. Even last week, in some situations, there was certain functionality that wasn't implemented. So that gave you a little bit of a hint that maybe things were not as beautiful as I was saying. And in fact, when we look at napalm config, we're going to see that in action again. So without going into any more detail in this, let's look at the code that I have for this session. So let's look at the code. Now the code I've called napalm config example. You recall the last session we had code called napalm example. If you look at the beginning of this code and what we do with this for loop here, and then you look at the napalm example, you'll see that it's pretty much exactly the same. I'm going to be talking to the sandbox devices. I'm going to be doing a deep copy of one of the devices so that I can use both NXOS and, remember, NXOS SSH as my communication mechanism. So I will have, in theory anyway, 3 different devices that I'm going to be iterating through. And so that's what my devices dictionary is going to be. And I'm going to iterate my dictionary just like I did in napalm example. And every iteration I will have the device type. That's the actual key, which is going to be one of these 3 values up here. And then the actual device information. And that allows me to know how to communicate and connect to the device with information like hostname, username, password, and if appropriate, the port for communicating with the device. So I'm going to, once I go through this iteration, for every iteration, if it's NXOS, then I only need hostname, username, password. If it's NXOS, SSH, or iOS, both of those require the port for doing SSH. So I provide the port. I do an open. This is the same. In fact, why don't I just split right here, and you'll be able to see that the information, my for loop here, is pretty much identical. Let's see if I can get these close. So yeah, so this is pretty much the same as the other. I'm going to do an open and then begin to do stuff. I've got a little bit different print statement wise. So let's go back to our config example. Once I have opened the device, this is what I'm going to do. And here, this is all the code that there is. So I'm going to go at a high level. I am going to get the current configuration for the device. So ignore this detail for right now. I'm going to come back to that for sure because it's very important. But the basic idea is I'm getting the running configuration with NXOS. I need to type of device. I need to get the checkpoint file because they do something differently. And remember how I alluded to the fact that I lied and that it wasn't one single interface. Yeah, that's kind of one of the examples here that I need to do something different for this type of device because of the way that the Nexus devices do comparison of previous configurations. So I'm going to get the configuration exactly as it is. I'm going to write it out to a file. So you may have seen all of these configuration. You maybe didn't know that they were config files, except that they end in .config. But these have existed for a while. I've modified the code as of this morning, so it writes things out a little bit differently than the way that it did before. But this is what we're ending up doing. We're going to write it out, and the reason that we write it out is because we're going to call into NAPALM device and we're going to say load replace candidate. And the typical way to do that is to say, here's a file name that has all of the information that I want you to load as a potential candidate. So the idea with load replace candidate is you're telling Cisco, hey, here's a configuration, here's a file that has configuration in it. I want you to look at this and consider have it alongside the other one as if I was going to replace it. I'm not actually doing the replace, so we're not actually replacing it. We're just doing a load replace candidate. All right, now this would be different. There's also, I think it's called load merge candidate, so you can do little snippets of configuration. That is a little bit easier, but this would be the idea here. We want to compare what's out there with the version that we have stored somewhere. Now, let me just go ahead and describe what the code does. The next thing that we do is we call into the NAPALM device and say, I want you to compare the thing that I just loaded with the existing configuration. And you see I'm setting this variable called diff to point at the difference between the two. And then I'm going to actually print it out. So let's let this run. It does take a while, so I will probably do what I normally do and either just speed it up and have it go fast, or else I will narrate over it. So let me run it. NAPALM config example. Let's let it run. So I've connected. Now I'm getting the running configuration from that device. Now I'm doing my load replace candidate. So this is actually going to take the configuration that I just got. I just saved it, so it should be exactly the same as what's currently out there, unless somebody made a change just in the 30 or 40 seconds that it's been. So I'm putting that out there. And the next thing that I will do is I will do this compare configuration step. So we're going to see where we're comparing the configuration. The next thing that we'll do after we're done that is we will write out the diff. And guess what? For my IOX device, I'll just scroll back here while that other one is going. It says there's a diff. And this happens to me every time. The banner always seems to be different. The configuration that I get back either is incorrect or it has more information or something. So this banner for me, in all the time that I've run it, has always been different. And I haven't gone in and tried to figure out exactly why. I will tell you that when you look at the Quakka, I need to get Quakka up here. Where's my Quakka? That's one of the reasons that my CSR configuration is always going to end up being wrong. But let's go back and let's see how my Nexus device is doing. It ran. So it connected to the device. It got the configuration from the device. And remember, this is a clue as to something we're going to talk about. Instead of doing a get running config, I had to say get checkpoint file. This is a nuance or a difference with Nexus devices from other devices. So I got the configuration, which was a checkpoint file. Then I did my load replace candidate that sent that data out to the device. Then I said, okay, I would tell the device to compare the configuration for this NXOS device and now print out the output. And remember up here, this is printing out the output that I got back from the diff, and that shows, that shows up to this minus this control C. And down here, my diff output is there is none because the two are exactly the same. So that's a very high level view of what I'm doing. Let me dive a little bit deeper into this. So let's look a little bit closer at this code. Now we don't have to look at this part of the code because we did that in the last session and I did talk about it in more detail there. The stuff that's new is what's right down here. So let's have a look at what we're doing. Now, as I mentioned, the first thing that we're going to do is we're going to try to get the configuration that we can use for comparison. And one of the things that I just learned today, and I learned it by Googling this and looking up issues that people had and figuring out the way that I can overcome this. And there's actually documentation that in the NAPALM realm that talks about this. Instead of getting the running config, as I and maybe you are used to for Nexus devices, they do something related to checkpointing. And so what I end up having to do is I have to call this method called underscore get checkpoint file. Now the underscore at the beginning, remember, there's no rule, but it's a convention that indicates that it's an internal function. And so if it's an internal function, typically you would not call it, but this is what has been recommended in the NAPALM documentation. So I'm going ahead and calling that. Now you can see that PyCharm gives me a little squiggly beige-ish line, whatever color that is. It says access to a protected member of a class. Unfortunately, I don't have any action that I'm aware of to get rid of that, so we're just having to live with that. But you can see there's the underscore. That's the indication. And this, remember, is the thing where we want to eliminate as much as possible. If it's this device type, then do blah. And if it's that device type, do something different. We would like our package that we're using not to make us do that. But unfortunately, we had to do it here. This was for an XOS. Notice up here, I'm having to check for both because I believe this is just a Nexus device type thing that you have to do checkpointing. Now, one other thing I'll point out, and this is something that I didn't mention. You may have seen this. I forgot that I had done this. What if it's NXOS? That means we're using NX API to communicate with the device. What? Why do I have continue there? Continue, what is continue going to do? So put your Python hat on. This says go to the next iteration of this loop. And what are we iterating? What's the loop? It's right here. It's way out here. So I'm going to ignore devices that are NXOS device. If it's NXOS underscore SSH, remember that's a different type of connection, then we're going to do that. And what is my comment here? Remember I said comments that are unnecessary just clog things up. But here I've determined, because I always get a bug, I always get an exception when I do this, that it seems that there's a bug in NAPALM for this device type. Or maybe it's not supported or something. But I get an exception. So this morning I wanted to go ahead and do this lesson. So I've not investigated that further. It may be at a later point in time because I do think I may do another NAPALM session later on. Then I may revisit this, or I may do it in the Quakka code. But anyway, so we're ignoring it if it's NXOS. So we're only doing SSH type devices, whether it's an NXOS SSH or an iOS device. And here we're getting the checkpoint file. In this situation, we're getting the configuration, and we're taking the running config. So we're getting the running config. So that gives us the information that we want. And now we're going to write it out. So if I was to look at this for iOS, the file I'm writing it to is cisco.ios.config. Let's see if I can find that. There it is. Sure enough, this looks like a configuration file. And now let's look at this cisco.nxos.ssh.config. I just want to open this as a text file. And here is my checkpoint format of the NXOS file. So this doesn't look like running config, and it's supposed to not look like running config. It has a bunch of these exclamation point pound signs in here. It has things looking maybe a little bit different than what you're used to, or maybe you are used to it. It could be just me. I just haven't dealt with them all that much. But this is what this configuration looks like, okay? So these are the configuration files that we're going to be using when we end up doing our load replace candidate. That's the next thing that we do, and we pass in the appropriate file name. And remember, my file name has this device type, so if it's iOS, then it's going to be cisco.ios.config. If it is NXOS, it will be _SSH, then it will be NXOS_SSH.config. All these other ones that you see, these are attempts that I made at trying to get this to work earlier on. So technically I could probably delete every one of these and it would be a little bit simpler. I'll probably do that, but I'm just not going to do it right now. In fact, when I originally wrote this, I thought, oh, I'll just save it and save that as the standard config. But what I decided to do instead, I decided to write it out immediately and then do the comparison. So I do my load replace candidate, passing in the file that I just saved. This is exactly the same as this file that I just wrote right here. So I'm going to do load replace candidate, and then I do compare config, and that allows me to get the diff. And that diff, in theory, if the diff is nothing like it is for my Nexus device, then I know the configuration is correct and I don't have to worry about the details. If it's different, then I may need to do something different. I may need to figure out why is it different and maybe make some changes. Now, you're probably thinking, because you understand how things work, what if the configuration, like in my iOS configuration, I don't even know, yeah, I have my host name here. Wouldn't the host name be different? Yeah, the host name would probably be different. So maybe in your code, when you're checking things, what you end up doing is you say, let me look at the diff, and if it's either the banner, which this failure one is, remember it failed on the banner. If it's just a banner difference, or if it's a host name difference, then I say, okay, well, I'm going to ignore that, and it's not an issue. So in your code, you can actually ignore certain clauses in your configuration if you choose to do so. That would be something for a real world type thing. The way that we did it in the project that I worked on, there were devices in different domains that if they were a particular type of device, they would have the same configuration. And so that's kind of what we did. I don't recall that we did anything special with respect to the host name. They were iOS devices. I think the comparison was done using something perhaps different than this NAPALM stuff. But that is an example of where you would use this in the real world. So the next thing I'm going to do is show you my code that doesn't actually work, but where it exists in Quakka, in case you're interested. So let's take a look at where Quakka does its configuration comparing. Now, you're probably not surprised to see that it is in the controller package. Inside the controller package, I have all of these monitoring tasks, and I have one called compliance monitor task, and that's what we're looking at right now. I have a number of functions that I have within this module. I can check the version, which is what I call from check OS compliance. And then what I also have is check config compliance. And this is where I go and figure out if the configuration is different from a standard. And I have saved a standard configuration file out in the Quakka data area. And that is what you see down here. These are all the different ones. You can see I have a bunch of different ones. I've had this gives you an idea that I at least tried fairly hard to get this to work correctly before I ended up bailing on it. But we should just look and say, okay, well, where am I checking it? Config diff. Okay, so here we are in config diff. I have the device. I have the configuration that I'm going to compare this device's configuration against. If the device is a NAPALM device, I need it to be NAPALM in order for me to do these things that we've been looking at in this class. If it is, I get the NAPALM device, I open it, and then I can do my load replace candidate, and I pass in the file name of this configuration that I am comparing it against. If it's a Nexus device, it will be that checkpoint type of configuration, and if it's an iOS device, then it will just be the running config. Once I have done that, then I can say compare these. This, as you know, is going to return the diff between the two, and if we go back to where we called the config compliance, here's where I called config diff, then I'm going to have this diff, and if the length is greater than 0, then they're not the same, and we are going to print something out to that effect, and we're going to set the status for the configuration compliance to be false. Otherwise, we say that it's true. And as I think I mentioned, perhaps what I can do is I can modify this so that it does a more intelligent job, doesn't just look to see if the length is 0, but it also will look and it will ignore things like banner changes or host name, maybe that stuff that we don't really care about. So that is this thing right here that we just looked at. That is how we use NAPALM to check the configuration to see if it is compliant with some standard that we have stored. Okay, so let's talk about what we learned. In our previous lesson, we looked at NAPALM and we were mainly just getting information from the device. In this lesson, we talked about doing configuration type tasks with NAPALM, mainly comparing configuration against some standard. That's the main use case. And the compliance screen that you see in Quakka is an example of doing that. You can see these particular devices out there in the sandbox are always getting changed, so naturally we would expect the configuration to be out of compliance for that. We talked about how in general with things like NAPALM that provides you wonderful abstraction, it works great in theory. Sometimes there are differences, and we had to deal with some differences in our example code. So we went through this example code, which at the top looked exactly like the other code that we used in terms of our for loop and the dictionary of devices. And for every device, after opening it, we retrieved the configuration. Now, for normal devices, we were able to just get the running configuration. For Nexus devices, we had to do this _get checkpoint file, because in order to be able to do this function, load replace candidate and then compare config, we need to have a checkpoint file for NXOS type devices. But whatever the case, we have a configuration to compare. We wrote it to a file, and we do this load replace candidate. That goes out to the device, and it loads our replacement candidate onto the device. And then we say compare config, and what is that going to do? It's going to compare the replacement candidate that we just put out there with the one that is existing and running. And if there's a difference, then it tells us the difference, and that difference we print out here. And so our output showed us what that looked like. So, and then we went into Quakka, and we looked a little bit at what Quakka did. We saw that we have this configuration monitor task that eventually calls config diff. Config diff is where we do the NAPALM request. Now, this is pretty much the same as what we did in the example. We're doing an open, and then we do a load replace candidate, and we do a compare config. By the way, little side note, if you have been keeping up to date on Quakka code, you will notice that the version that you have out there actually says load merge candidate. That's what I was using in a previous version, but since I've done more with the NAPALM config example here, I've changed this to load replace. So this is where the magic happens in terms of comparing the configuration and giving us, hopefully anyway, this interesting information here. And if I had a network of devices, I would be able to have intelligent config stuff. I did have CML up and running for a while, but I do not at this time, so I'm not able to show you that. Anyway, I hope this has been helpful to you to understand how this NAPALM is able to be used to compare configurations against the standard. Here's my example of doing it with multiple devices. Oh yeah, and that business about having to check for different device types. It's annoying, but sometimes you have to do that even if you have abstraction. So I hope that makes sense. I hope this will be helpful to you as you maybe go forward using NAPALM in whatever project it is you're doing that does configuration of networking devices. Thanks for listening.